up, then I saw her in the crowd, and I looked her in the eyes.
Hi everyone, I'm Tamara Davis. I'm a professor of astrophysics at the University of Queensland, and I'm here to welcome you to Wake Up to Astronomy. I'm really excited to be able to answer some of your questions today. What I do, I'm a cosmologist, so as my job I study the universe as a whole. I try and understand the expansion of the universe, try and understand what makes up the universe, study things like dark energy and dark matter, trying to figure out the laws of gravity. One of the really weird things that we've discovered recently is that the entire expansion of the universe is speeding up. Whatever is causing that is called, we give it the name dark energy, and I try and study what that is. At the moment we still don't know. We're trying to figure out whether we need to develop a new and better law of gravity, whether we can combine quantum physics and gravity together, or whether it means that there's something out there that has some sort of anti-gravity push that we're trying to figure out. So I work in big international teams, working with a group called the Dark Energy Survey at the moment, and we just got some really cool results out on Friday where we made the biggest, most detailed map ever of the distribution of dark matter in the universe, which was really exciting. This group, we've got about 500 researchers all around the world, and we're trying to come together to measure the sort of fundamentals of physics that we can learn from looking at the sky. Now, you guys have sent some fantastic questions, and so I'm looking forward to answering them. I have a pile here of questions that you've sent in, so I'm going to shuffle these, and we'll have a little bit of a go and see what kind of answers we can get. So let's have a look here. Randomly picking one from the deck. What have we got? Okay, this one is from Jen. This is an interesting one. Is there a lot of guessing in astronomy? Not really. It's really scientific in that, we make observations and look at in great detail at the sky, and we have a huge amount of information now. The power of our digital cameras on enormous telescopes means that we can see enormous detail about the universe. There's always guessing. We sort of make hypotheses, what could be causing the acceleration of the expansion, for example, and then we go out and we test those hypotheses and see if they match what we observe. So I guess that's that. We try to guess as little as possible. Whoops. I dropped someone's question. Okay, let's try this again. What have we got for question number 2? Oh, this is a good one. Is it worth all of the money that it costs to put a telescope in space, or are the ground ones adequate now? This one's from Bella. Thanks, Bella. Awesome question. Putting telescopes in space is still worthwhile. The ground-based ones, we've got all these fancy things like adaptive optics, which means that we can take into account some of the bending of light from the atmosphere that makes stars twinkle and make images look blurry. But even with that, it's still worth going to space, because if you're trying to look in the ultraviolet, for example, we've got this whole spectrum of light. We've got, the rainbow that we see, sort of red to violet, but there's a huge amount of wavelengths outside of that range that are being emitted by the sky, by the stars and the galaxies and nebulae and things like that. And those are wavelengths that we can't see with our eye. We can look at radio waves here on Earth, and microwaves we can look at, but we can't look at things like ultraviolet and X-ray and gamma ray. There's a good reason for that, and that's because our atmosphere prevents that light from getting to the ground. So we have to go into space if we want to look at gamma rays, because with things like our ozone layer won't let a whole bunch of different types of light through. So going to space is definitely still worthwhile. That's quite apart from the fact that you also get much clearer images when you don't have the atmosphere blurring, even with our best technology that we have from the ground. Cool. Okay, so let's see what else we've got here. Next question. Is there a black hole at the center of every single galaxy? This is a great one from Oscar. As far as we can tell, yes. We've measured every galaxy that we've been able to measure in enough detail has a black hole at the center. So these are supermassive black holes that are millions to billions of times the mass of our sun. and really dramatic cause to all of the galaxies. So I study some of these. Actually, we're monitoring 771 supermassive black holes at the centres of distant galaxies. We can't see the black holes, but we can see the hot gas that falls into them. And we're checking out that gas to try and measure things like the mass of the black hole, etc. It's pretty fun. Okay, and next, I'll shuffle again. Which other planets have water on them? That's a great question. We don't have a complete answer to it, but we definitely know that there's a bunch of water all over our solar system. There has been water seen on Mars now. And there's some of the moons of Jupiter, for example, have enormous oceans under really thick layers of ice. And they're one of the sort of top spots that we might find life existing on in our solar system. And of course, we now know of thousands of planets around other stars. And in the next few years, we may even be able to measure some of what's in those atmospheres, which is really cool because we can see if the conditions for life are there, and we can actually even look for molecules that might indicate that life exists. Like if we see oxygen out there, it's on Earth, oxygen is made by plants, and oxygen easily gets used up. It gets used up when you burn stuff. It gets used up in rust, etc. So it's hard to keep oxygen in the atmosphere. If there is stuff there, it's probably being generated by something, which could be life, which would be really fun to find out. Okay, shuffling again. Oh, this one's funny. You're obviously very smart. Why did you become an astronomer and not something else? Well, first things first, being smart is useful, but the thing that makes you a really good astronomer or a researcher is curiosity, fascination, interest, and a huge amount of persistence and determination. Those are sort of the key aspects. I'm doing astronomy because, seriously, it is the most fun thing that I can possibly imagine doing with my days. I wake up excited to go to work. I get to show up at work and try and figure out how the universe works. And not only that, try and figure out, I get to choose my projects. I get to choose what I think is the most interesting question to work on and get to do that. I think no other job gives you the opportunity to really direct your own sort of research in life and spend so much time intensely studying something you're really interested in. It's a great job. And you get to travel around the world and meet lots of interesting people. So I wouldn't be doing anything else. Okay. Oh, because you gather so much data, does that mean that every astronomer has to also be a software engineer? This is a question that came from Will. Sort of, yeah. If you're planning to become an astronomer or a researcher in general, then I highly recommend concentrate on being really strong at maths and calculations, strong at physics, but also really be strong at computer programming. It's a really useful skill and pretty much an essential skill if you want to be an astronomer. Even if you're a theorist and don't work with any data, we use supercomputer simulations to simulate the universe, and a lot of the theory that is done using computer programs as well. So very important. Okay, we're going great guns here. Cycling through. Let me see what's next. Okay, question here from David. Is science very competitive? Do people keep their findings to themselves because they want to win a Nobel Prize? Yes, science is very competitive, but no, people don't keep their science to them or their discoveries to themselves because they're not going to win the Nobel Prize unless people realize that they're the ones that discovered it. Astronomy in particular is a really collegial science. We really work together. Like I was mentioning before, I work in this team that's almost 500 people from 6 continents on Earth. And it's a really international endeavour. And because we're all looking at the same sky and we're all using the same really big telescopes for many other different teams, not just this one I was talking about, we tend to work together a lot. After we take observations with these really big telescopes, all of the data becomes public. sometimes we have like a proprietary period of about a year or something where we can analyze the data before it goes public. But apart from that, it all goes public, and you can download it. Anybody can download it, because we think this is a resource that everybody should be able to have access to. Science is pretty competitive. There's a lot of sort of competition for jobs. There's not that many jobs doing research, so there's competition for that. But if you do an astronomy degree or do a physics degree, you end up qualified for so many different things that no one ever has difficulty getting a job with a physics degree. You can go into, there's software sort of stuff that you can do. Some of my friends have gone into medicine, things like radiotherapy and designing ways to treat cancer. Other people, I know people have gone into art restoration. And anything basically where you need to sort of do something quantitatively in business is super useful to have a physics degree, because taking real life situations and calculating quantitative, like really solid predictions of outcomes is what physics does. So yeah, very high demand for physics graduates. Okay, shuffling the cards again. I apologise if I don't get to everybody's questions, but here's a great one from Dan. The question is, will our galaxy eventually collide with another one? If so, what will happen then? I love this question. So yes, in fact, we're on a collision course with Andromeda right now. And even before we hit Andromeda, the Magellanic Clouds are two little galaxies that are already sort of they've already had encounters with the Milky Way, our galaxy, and sort of they're orbiting now, so they're going to slowly merge. But we're falling towards Andromeda, which is actually a bigger galaxy than us. The cool thing is, though, that even though both galaxies are filled with hundreds of billions of stars, when they collide, all the stars will basically miss. There is so much space between the galaxies, between the stars, that the likelihood that any stars are going to collide is really, really small. So even when two galaxies, massive galaxies collide, they basically pass straight through, or at least the stars do. The gas in the galaxies, which is floating around between the stars, that will hit and have some pressure waves and heat up, and you'll see some pretty stuff like the kind of thing you see in the nebula behind me. But you have, excuse me, but it's amazing. They'll go through and then they'll slowly sort of come together, and that will be they'll eventually merge and form one bigger galaxy. Okay, it looks like unfortunately we're already on time for the last question of the day, and this question is a special one from Madison, and they ask, how far back into time can astronomers see now? Can you see all the way to the Big Bang? Almost. Really, really close. The universe is about 13.8 billion years old. Excuse me. And we can see almost all the way back to the beginning. We can see back to 380,000 years after the Big Bang. Excuse me. And that's something called the cosmic microwave background. That's sort of a microwave radiation that we see from almost the beginning of the universe. And it's some of the more detailed stuff that we have from the entire history of the universe, and most detailed information that we have about what makes up our universe. So yeah, it's really amazing to think that we can see so far back in time. Great. So I guess that's all the time we have for today. This has been a rapid fire thing to answer all of your questions. I hope that you've had an interesting time, and I hope you go out and explore many more things about astronomy and enjoy discovering a little bit more about the universe. Thanks for watching.